known cases about this is, imagine that you develop an Android application. Sometimes you put that game, some application, some game for your phone, you put that into the cloud, and something happens. 1,000 people start playing your game. And after that you say, wow, I would like to get some information from this game. So how people is using this game, how people's, which features of this application people is using and which is not. Now imagine that you have 1,000 users. So you can imagine that you have like 1,000 of touch in your screen, maybe per day. So how do you collect that data and how do you perform queries over that information, because you want to sell your application, because you want to improve your application. If application improves, you will get more users. So this is the main topic of this presentation. My name is Eduardo Silva. I have been doing open source development and that similar stuff for about 12 years. So what I like from open source development, it's about collaboration. That's my GitHub link and Twitter. You know, in open source stuff, the GitHub is your new profile. My Twitter, personal blog, for the company that I work for, and the projects that I have been developing in the last years. So basically, I'm a developer, developing on Linux and embedded Linux, mostly on C, and trying to create new technologies and looking for ways to improve what we currently have. Sometimes you can have a very good solution one time, but after 3 years, you have a different context, a different area, or a different technology. So I like to improve, I like to create things, and that are my contact details. So we're going to start talking about logging. Logging is the art of collect some information. And logging matters, and we have many things that are very important for that, because you can get application status. We're talking the software context. If you have some software, you want to log what's happening. If we get an error, we need to be able to troubleshoot the problem and try to find the root cause. And of course, logging can happen locally or in a server. When we talk about internet, servers, Linux boxes, sometimes we're not just talking about one box, maybe 100, 1,000. So logging matters for that. And from a business point of view, logging is very important because you can improve, you can increase your sales, increase performance, and many things. But when doing logging, there's a few assumptions that people do. And usually it's this. For example, usually when you do logging, you use your file system, a hard disk, an SSD, or whatever. And you assume that you have always enough disk space until your application crashes. Sometimes input-output operations may block. Log messages needs to be human readable. When you develop an application, you need to trap exceptions and sometimes write that exception to a file or to some service. But if one time you implement like 5 kind of messages, and the next day another developer comes in and implement 10 more, you have 20 error messages, and most of them have different formats. And that could be a problem. And your logging mechanism needs to scale. So it basically should work, but sometimes it doesn't. So the main concern is if your logs increase, your data will increase. Your message format gets complex. Your operating system sometimes did not flush the logs to the file system properly. If your application is using threads, it may be slogging, and you may face some performance issues. So, and if you have multiple applications which create multiple logs, and you have multiple hosts with multiple applications, can be a mess. So basically, logging matters. It's really beneficial, but it needs to be done right. When you develop software, you need to make sure that the application works. But sometimes you have bugs, you have problems, and you need to troubleshoot that. So a common source for logins in the common real world, we can talk about web servers, for example, Apache, Nginx, Syslog, or any custom application that you write in your own language, C, PHP, Python, or anyone similar. But here in a galaxy not so far away from here, this is what really happens. Sometimes you want to collect information from all your applications from all your services, and this happens. You have many sources on the left, and maybe you want to perform some analysis on backend database, like MongoDB, MySQL, or any cloud service. And this is a mess because you need to write scripts on Python, on Bash, or any kind of scripting language. So what happens when you create new applications or when you want to unify these streams of data? And how you can parse that information, that is a problem. So that's where comes an open source project which is called FluentD. Any one of you is a developer here? Raise your hands. Yeah. Okay, do you develop PHP, Python, C, Java? Okay, cool. Do you know Logstash, for instance? No, okay. FluentD aims to solve the problem that we specified before. Basically, FluentD is an open source data collector. So no matter what kind of input data do you have, FluentD has many kind of input plugins to support that data of information. So this is the scenario that we used to have right now. Maybe you want to collect information from your Twitter client for your Android application, and you want to perform some big data analytics with Hadoop, with MapReduce, or you want to push something to Elasticsearch. So, and basically FluentD comes here to try to solve this problem. FluentD knows how to gather information, knows how to parse information, and the good thing is that FluentD uses an internal JSON format. So everything that you have a big string as a full message can be converted to JSON internally. Its high performance it has built-in reliability because at some point you don't want to lose messages, you don't want to lose data. If some application crashes, the solution is not just to restart the service. The solution is good for the root cause, try to troubleshoot, but you need that information. FluentD supports plugins. We have more than 300 plugins around the world, and we have thousands of users. And the architecture is pretty simple. We have an input where we gather the information. We have a parser. After you get information, you want to parse what did you get. You want to filter. Maybe you just want a fraction of that information. And you need to buffer that information. Why? Because if the point of where you're going to push that information out, what happens if the network is failing? You don't have enough disk space. Okay, you need to keep a buffer of that information. And then we support outputs and formats. So this is a pretty straightforward workflow on how you can collect information, and FluentD do this. Well, this is the internal simplified. So every time that we get some information, any string is handled as a JSON format internally. We don't use JSON, we use message pack, which is a binary version of JSON. But the format that we always try to keep in mind is always at a timestamp, a tag because you want to identify from where this information is coming from, right? And the record with different fields. So the input plugins aims to retrieve information or go for that information at some point. Okay, and the output plugins, of course, write that information out to our place. Buffer allows you to improve performance and put some strong service in the middle. And what happens if you have a gigabyte of information? FluentD manages all that in small chunks of data. It aims to improve performance always. So this is one kind of workflow and architecture of FluentD. We're not going to talk too many details about it, but basically every time that we have some input data, we go to filter, to buffering, and we can do some routing for the information. Okay? So if you have 1,000 of services, okay, 1,000 of servers, and you want to collect information from them, what you're going to do is maybe you just need more than one FluentD. So FluentD can talk to each other, so it supports some routing. And of course, the output, we can see how the chunks can be distributed to a queue, and that queue can go out to a network, file system, or any kind of database. So basically, we try to solve the mx by n by x plus n. And we can do simple forwarding. This is pretty cool because you can collect information And maybe you don't need to create your own database with your own tables to use SQL. Maybe we can push directly to MongoDB or to PostgreSQL. And this is an example of how you can configure FluentD. Basically, this is a configuration file which has 3 main tags, 2 sources. Let me see how this works here. For example, in the first source means tail. Tail, what it does is tail a file. It always looks for the last information that was written to a file. So in this case, we are tailing the Apache web server log. So every time that you get some request on your web server is recording that information to a log file on that specific format. But FluentD knows how to parse the Apache information. Okay? Once we get that source, we need to make a match. A match means, okay, if I got this information, what I'm going to do with that? The match allows you to match the tag, which is vacant on this case, and perform some operation. On this case, we're going to push the information out to a MongoDB database. And sometimes we have some more complex case. When you get some information and you want to distribute that same exact message or event to different services. So for that kind of cases, for example, imagine, have you used Elasticsearch sometime? Okay. Elasticsearch is a paid cloud service on which you can insert information and perform queries over that data. But if you have 1,000 of records, that is fine, it works pretty fast. But if you have 1 million of records, that will take some time. So that's why, that's why this other guy exists, which is Hadoop. So in this case, we're going to demonstrate how we can play that in a different way. We're going to take the same example of where we get information from Apache. And we're going to match here every tag vacant with an asterisk here, with a star. We're going to use the type copy. Copy means that we'll copy that message to any store that we have defined. From every message that we get from Apache, we're going to perform a copy to the Elasticsearch service, and also we're going to push that to Hadoop. Hadoop aims to perform MapReduce operation over a lot of data. So basically, this is about how you can retrieve information and push that out to any place. So basically, okay, I can be talking a lot of things how FluentD, but who uses FluentD in production? Basically, Line, GRE, Google Kubernetes, who manage container stuff, Amazon Web Services, Nintendo. And all of these start as an open source project. The thing is that it becomes an enterprise-ready solution, and it's free. It's free to use, free to implement, and free to hack. And also, we use it at the company, because as you know, as a company, when you have different needs, you need to create solutions. And most of these solutions that we do to collect information are made for treasure data. Because with FluentD, we collect every day, well, 800,000 events per second. So imagine that all of customers that we have, we need to collect information from them. And we collect this amount of data, which is a lot. Of course, we have more than one FluentD for that. One is not enough. So that is pretty cool. Let me talk about a simple use case that we have now, which is called the Internet of Things. Have you heard about it? IoT? Okay, cool. Okay, the thing is, in IoT is growing a lot, in the order of billions per devices for the next decade, or in a few years. And now, this is not about communication between devices and cloud services. It's between device to device, which is a bit more complex. And to deal with this, we have different frameworks. IoT, we will see in the next slide, that we have different frameworks and protocols that companies are implemented for this. And of course, there's the same need. It needs logging. So basically for IoT, we have two main alliances, the Open Interconnect and the OSINT alliances. What that means, that a group of companies are trying to join to the IoT market. because it's a bunch of money. But all of them needs to standardize which kind of protocols are they going to use. So basically, for example, Open Interconnect provides the IoTivity framework. All of this is open source. And All Scene Alliance provides AllJoin. And what happens when you have IoT devices and you want to solve the same need? Big data collection. You want to perform analysis of data from billions of devices. Okay? So you need a generic solution that works properly for that. So that's why we created FluentBit. The difference between FluentBit and FluentD is that FluentD it's made in Ruby language plus C. And FluentBit is entirely made in C language. Okay, this works for embedded Linux, is compatible with Yocto project, with Open Embedded, and all that initiatives. So it's open source. We started this project this year, and we aim to target these needs, everything that's related with sensors, everything that's related with small devices, and basically anything that runs Linux and is related with IoT. And basically, when we designed this project, we said, okay, we need that this project be lightweight, needs to be written in C, and it needs to support plugins, and of course, it needs to support FluentD, because it's aimed to be integrated with FluentD. So this is the first approach that we have, on where you collect information from your data source. It can be a sensors, XBs, any kind of radio device. Then you can collect that on point number 2. Any device running Linux, you can run FluentBit on that. And you can use FluentD. FluentD for what? To push out that information to any cloud service outside of that. Well, and we also implement, which is a direct output. So if you have a Raspberry Pi, a bigger board, you can run FluentBit on that and push that information out to a MongoDB service, Amazon S3, or anything. And we're going to talk about containers. Do you know what Docker is? Do you know what Docker is? Do you know what a virtual machine is? Okay. Let me explain a bit about containers. Usually, when we have a bare metal machine, we have one operating system running on that. Okay? The virtualization concepts comes to input some technology in the metal on which you can abstract the hardware, and you can put many operating systems running all together, right? They think that they are unique, but they are virtualized. They have an hypervisor. The containers technology is something that has been around for years, but recently in the last 2 years has become famous with Docker and other kind of solutions like Google, which provides Kubernetes. With containers, you don't need virtualization. You can isolate an application in your system, and you can assign specific resources for that application. And what I mean with that your application will have, I don't know, 1 gigabyte of memory, will have access to this kind of network interface, and that's it. So you can restrict. If something happens with your container, the container will just crash or stop, but your environment will be pretty safe. This is implemented on Linux, of course. So what we did, well, we were looking for containers, and we see that, okay, people is using a lot of containers right now. If you go to see production environments, people is using virtualization, bare metal, and containers. And we say, okay, containers also needs logging. They need to log what's happening with the application, troubleshoot errors and everything. So basically what we did was to create a complete integration of FluentD inside Docker. And how that was accomplished? Because Docker 1.6 implemented the concept of logging drivers. What that means that Docker said, okay, which kind of drivers I'm going to use to log the information from the containers. So basically, we send a pull request for the Docker team. Everything is open source. We did it through GitHub. Our colleague, my colleague Tagamoris did that. And basically, we implemented the FluentD driver for Docker. So now if you get Docker to play with containers with Docker 1.8, you will get the driver inside that one. If you want, we can make a demo right now. I don't know if you would like to see how that works between Docker, FluentD, MongoDB. Okay, let's play with that. Okay, the first thing that I'm going to do is to start FluentD. Can you read, or it's too small? It's too small. Okay. Better. Okay, I'm going to show you a FluentD configuration file here. Just that I made this for a previous presentation. Basically, you will see two tags, one which is called source, right, the first one, and the second one which is called Docker. This is not the right configuration file. I did a mistake, so let me put you the right one. There we go. We're going to play with MongoDB. That is the one. Okay, basically the source said, okay, FluentD will be listening for messages on the TCP port 24224. Okay, and every message that it gets, FluentD will flush that out back to MongoDB. Do you know the MongoDB database? Have you used it before? Okay, it's pretty famous right now. This is just an example. Okay, so we're going to run FluentD and make it use this configuration file. Okay, there we go. So basically it said, okay, I started, I read this documentation, I'm already listening for messages on this TCP port. Okay, this is the login stuff. The most interesting thing is that here I'm going to start a web server. A web server is a server side of the HTTP protocol which gives you access to resources that it can mean images, files, process some PHP scripts or whatever. So here I have a container which runs a Monkey Web Server. Okay, the container is starting. Okay. Let me show you how the web server works, because you know that is just a command line. Okay, that web server is running on the local host, my own machine, on port 2015. Okay, there we go. Okay, the web server is running. Okay, in the TCP port 2015, I'm running the Monkey Web Server. This is locally. All of this is happening inside my machine. What I did, okay, on one side, there's the web server running on Docker. Okay, but when I started Docker, you can see this line. I basically said, okay, run Docker. Okay, run Docker on the TCP port 2015. The internal web server is running in 2001. Then use the login driver FluentD, and please start that container. Everything that you're getting here are the web server logs. The web server is configured to write the logs to the standard output. So that means from this TCP, this IP address at this time, I get a request over this resource. For example, an icon, a font, an image. Well, the first one is the index file. All of this content was the main web page. Okay, but what is important here? We said, okay, Docker is flushing information to here, which is this guy, FluentD. And FluentD is configured to send information out to MongoDB. So here, I'm going to query the MongoDB database. Okay, in the configuration said that we're using a database which is called FluentD. And now I want to query the information that the Docker container on the other end just created. Wow, that's a lot of information. Okay, what we have here. If you recall, in the first time we had the Docker container running the web server and running information out to the standard output. Okay, look at here. Here's my register. This is JSON. Do you know JSON? The JSON format? Okay. Okay, we have the ID for the object. We have the source from where we collect this, the IP address, and all the log from the web server. What that means? Okay, this is a simple use case. We have one Docker container running a web server, pushing information out to FluentD, and FluentD to MongoDB. What is interesting here, if you have 100 of containers, or maybe 1,000, and you want to query all of their log files, you can use this approach, or for your own applications. Because everything, the configuration was pretty simple. You get a JSON format, and you can query this with Mongo tools. You have a web interface, you have the command line, and everything. Do you have some questions so far? It's pretty clear. It's not. Okay, I hope that you like the presentation. This was mostly about how to collect information with the FluentD. This is the information for the project. If you want to collaborate, spread the word about the project, all of this is open source. Just let us know. We are just flying around the world, trying to teach about data collection with this open source tool and trying to engage more people. Here in Costa Rica, there's a lot of people doing open source stuff as development, but we're trying to reach them to try to engage them, try to make some development, collaborative things. So, well, my contact information, I have business cards, stickers if you want. So, well, thank you. Thanks for coming. Do you have some questions? Spanish? Okay.
What can I do with that data?
What you can do with that data?
Yeah.
Okay, it depends of what are you doing initially. Okay, when you get a data, of course you want to do something. For example, on this example, this was a web server. Okay, imagine that somebody is performing some denial DOS attack to your web servers. They are trying to put your server down, and you want to identify who is doing that, and that who is the IP address. One case, for example, maybe you have a fancy web page where you have a lot of programs where people can get them, and you want to know how many hits each file do they have. Okay, you can do that using the command line, looking at your log files, or you can put that in a Mongo database, Redis database, and use some cool query language for that.
Can I use SQL, like the database for Android, SQLite?
Yes, you can do it. For example, FluentD as an output support many different kind of databases. For example, MySQL. If you want to use SQL, you can use MySQL, PostgreSQL. You're not going to use Mongo, of course, because Mongo does not support SQL. But you can create your own tables and tell FluentD how your data format is. And it will store with your format on your tables on your own database. Okay, guys. If you have more questions, I will be around. So thanks for coming.
Listo, gracias. Démosle otro gran aplauso, por favor. Está bien, gracias. Nos vemos mañana. Sí, hasta volver a estar aquí. Ya, ¿qué hora? Tipo 11. También recordarles, Eduardo va a volver a estar aquí mañana en una charla a las 11. ¿Cuál es el tema de la charla? Con el tema del desarrollo open source, por si quieren darse una vuelta. ¿Cómo hacer dinero con open source? Todavía mejor. También recordarles e invitarlos que ahorita a las 6 de la tarde tenemos una charla con Diego San Esteban, por si se quieren quedar por acá.